Welcome to the Getting Started tutorial video for beam detailing. In this video, I explain step by step how to use the beam detailer software as a part of beam detailing package. After installing the beam detailing installer, go to the beam detailing installation folder. Here you can see these files in this folder. In the manual folder, you have the beam detailing user manual and the beam detailing installation manual. You have always English and Spanish version. The installation manual. You have everything you need about how to install the beam detailing. In the beam detailing user manual, you have as well the English and the Spanish version. Because the English one, you have here step by step everything. In this manual, we have used an example, an ETABS model, to explain how to use the software. In this tutorial video, we use the same example to explain more detail about the beam detailer software. You have here a ETABS model folder. Inside you have the ETABS model, which is has been done in ETABS 2015, and you have also the XML file. If you are able to open this model, this will be nice. If not, you have already the XML file. Let's create a new folder. And let's use this file. You can do the same steps and you can learn more about beam detailing. Let's run the beam detailing generator and let's copy this path and put it in the ETABS path. If you open the file, you can select the XML file and click on generate. Once you receive this message, it means everything was generated successfully. You can close. You have here the generated file. The detailing generator always generates the same files with the same names, but for sure it's not the same inputs. Each of these files is actually a detected beam from the ETABS model. ETABS model, this is the ETABS model, this is the floor number 31 in this tower. Indeed, you have the unique names of each element. The detailing generator detects the beams with a tolerance angle equal to 15 degrees. So this has been detected as a beam. There's another beam, there's another beam, etc. The detection is always based on the support, or actually based on the joint of the beams. If you divide, like example, this beam between two columns to 4 beams, there will be generated a beam with 4 spans, which is more accurate. So it's very important always to connect supports by one element. Like example, in this case, we have this wall, this shear wall, and we have one beam between this column and this shear wall. The same here, the same here. We don't have any beam overlapped with the shear wall, and we didn't divide any beam to different elements. Well, so each of this text file is a beam, will be later drawn in the beam detailer. Also, you have the plan generator. This file will be used later to generate or to draw the geometry of the plan, of the selected plan. Other one is the plan beam detailing. The plan beam detailing includes all the detected beams together in one file. So from 1 to 14 or 14 beams are all of them are inside this file. This file will be used later to carry out the detailing for the 14 beams. So if you want to carry out the detailing for just one beam, you have to use one of this file, each one individually. If you want to carry out the detailing for the entire floor, you have to use the plan beam detailing one. You can always change the name of the files, but don't change any of the data inside the file, and also don't change any like extension. It's a out, don't change it to .ext, otherwise this will make it a confusion for the beam detailer. We can start now with the AutoCAD file, and the AutoCAD can be used, but it's better if it's AutoCAD 2010 or higher version. Go to Tools, Auto Lease, Guide Load Application. You have to load the application every time, and let's say in each session of AutoCAD for each file. You have here in the folder or installation folder, you have the in the back here, you have the beam detailer, ETABS, and SAP. Inside you have three files. The two files. One is for the English version, one for the Spanish version, and you have the DCL file. The DCL file must be in the AutoCAD support path. AutoCAD support path can be found by go to Program File, Autodisk, your AutoCAD, and here you have a folder that's called Support. Inside the support, you're supposed to have this DCL file. Okay, let's go again to the manual folder, ETABS model tutorial example. You have to load, like example, here I have the AutoCAD in English version. I use the English. If your AutoCAD is a Spanish AutoCAD, you have to load the Spanish files file. To load, you must receive this message, very important, that like was successfully loaded. Just like CSIB in the command line, AutoCAD, then this user interface will appear. This is the user interface of beam detailer software, which is to work inside the AutoCAD. Basically, this is a new function in AutoCAD. Once you load the fast file, it means you have defined a new function. It's a function as any function in AutoCAD, but this function includes many functions and many calculations and an algorithm to carry out the detailing for a beam or for a multi-beams and so on. Here you have three applications: plan generator, beam detailing, and plan beam detailing. Plan generator application will be used to throw the plan geometry of the plan by using the plan generator. So if you make this active and disactive the other, we have here only the path of the file and text file, or without txt or without out. Just copy the plan generator or wherever you change the name and click on OK button. It's a problem, because it must be selected here and the path file. It's OK again, and just a few seconds we'll have the geometry of the plan. Alright, like zoom extend the AutoCAD, we found that we have now this plan. In this plan we have different beams. This is a dicted beam. Each beam is assigned to a layer. Like example, here you have the layer number 1. This beam for the unique name or the element with the unique name 1385. This one, and this is a part of the main of the big beam, which is number 1. So if you open here the text file number 1, you will have the barrel it's called 103,085, which is this one. So in this text file you have all the design reinforcement, which is it's already extracted from ETABS in this text file. Beam detailer will read later this information. So beam detailer is not going to design the beam. The design must be done for sure in ETABS. And if there's a problem in the design, it is not like a mission of or a task for a beam detailer. The beam detailer just reads the result. So try to make sure that your design is okay first, then better use the beam detailer. Okay, like example, this beam number 12 has 3 components or 3 beams, 3 elements, 1381, 82, and 83. If we go to the ETABS, we have the same. And all are at the beam number 12. So if you open the beam number 12 here, the text file, you will have more information because it has like 3 micro beams. Let's call each of this element is a micro beam inside beam number 12. Well, good. So let's start to do the detailing for this beam number 12. You have to write again the command line CSI beam and make you should have to active the application beam detailing. And this here you have in the upper part is for the longitudinal reinforcement, and here you have the basic top bars, basic bottom. Basic top and bottom bars actually are quite important in the algorithm of beam detailer. Beam detailer assumes that you have a constant reinforcement along the length of the beam. This reinforcement is constant at the top and the bottom. Can be different or can be the same. And if this reinforcement is not enough, you can use additional reinforcement. So we don't know yet how much this reinforcement or the basic reinforcement must be, but let's put like 3 like example of 25 and 4 bar of diameter 25 as well. Let's put here 320 like example just to change. Good. So I have assumed now, because I don't know the design, that's okay. I'm gonna put 3 bars along the length of the beam at 20 millimeter and the bottom 4 bars with diameter 25. I can put, if I want, skin steel reinforcement 2 or number 12. If I want to put here, it's enough to put 0. In this case, the skin bars will be, you will not have any skin bars. Let's put 2 to number 12, or can change. Well, here you have the preferred top and bottom bar. This bar or this diameter will be used later to cover the additional reinforcement or the required reinforcement. It has already designed the beam and gives you the reinforcement. And we're gonna put some basic reinforcement, and the additional will be by using diameter, let's say maybe 25 for the top and 25 for the bottom. We have here a preferred extra bar diameter. This bar is to be used later for the additional bar. Like example, you need 4.2 bar of 25 instead of using 4.2. The 4.2 is not 5, so the 0.2 bar of 25 will be used as a bar of 12. This is just to, you know, like to save some weight. Okay, anyway, here you have the smart, I call this a smart selection. This is to control actually the basic reinforcement. As long as you don't know yet the amount of the reinforcement, so you can control by assuming a ratio. This ratio is the ratio between the basic reinforcement you use to the required reinforcement. In other words, this is having like 3 bars, 3 bars of diameter 20. If the 3 bars diameter 20 are more than 75% of the required top reinforcement, in this case, the software will automatically decrease the basic reinforcement by either change the diameter or the number of bars. So if you use the diameter, the software will start looking to the diameter that is satisfies the 75% or less. You start from 20, go from 20, 16, 14 until 12 in this list. The same for the bottom, or you can put number of bars. Number of bars, in this case, the software will remain on the diameter and will change the number of bars. Let's put 75 for the moment and then change the diameter because we don't know it. It is to draw like the envelope of the reinforcement. We'll explain this in a bit. But for the moment, for the transverse reinforcement, beam detail actually follows a smart algorithm to draw the transverse reinforcement. It's satisfied also the ACI 318 conditions and frame type. Here in the user manual, we have an explanation about all this and how the software will calculate the maximum space between bars in the confinement area and in the middle of the bar. The confinement is like 2 times the edge of the beam. This in the middle is the line confinement. Anyway, this is the condition. If there are any conditions or any requirements that are in the code, and they are not mentioned here. They must be satisfied actually by the user after carrying out the detailing. Let's select like frame type and intermediate mode is to frame. Minimum stirrup bar, let's take 12, and the maximum is used like a 20. As I said, BMDealer actually use a smart algorithm to calculate the transfers and calculate the number of bar, diameter, and in the same time satisfy the ACI conditions. So we're gonna use IMRF, minimum stirrup bar 12 and maximum is 20. Here this option is the maximum space between the bars, but this is at the cross section. If you go to the user manual, you have here, this is drawing, and this is actually the maximum space. Like example, if you put here the maximum space is 35. So if this beam is a 25 centimeter width, in this case, you will have minimum just one stirrup. But if this beam is a 50 centimeter, in this case, the minimum would be 3, would be one stirrup and one tie bar, because 15 centimeter minus 2.5 from the right and 2.5 from the left will be 45. 45, it's more than 35. In this case, the software will assume that you need to put another tie here, tie bar. And if the basic reinforcement, like example, is 2, in this case, the software will ask you to increase the reinforcement or will be done automatically to satisfy this additional tie bar. So let's give it as a 35. Minimum here span length to generate 5 the transfer reinforcement zone. BMDealer also has 3 options to distribute the transverse reinforcement. If the clear span of the beam, or let's say the clear span of any span of the beam is more than this number, in this case the BMDealer will distribute the transverse reinforcement for 5 zones, and this is quite nice, quite important and useful for a beam with a high span. Another option is this one. This is to generate just one transverse reinforcement zone. In this case, if the span is less or equal than this number, the software will distribute the reinforcement as a constant. It will be like one zone with the same value along the length of the span. And that will be based on the maximum value in this span. If the span is between this number, between example 700 250, the software will generate 3 transverse reinforcement zones. Material property, the concrete strength and the yield strength of the reinforcement are required to be input in here, and this is actually to calculate the development length of the reinforcement. Here you have, this is the formulation to calculate the development length in the ACI code, assuming one of these conditions is already satisfied. If it's not satisfied, the user has actually to modify it by itself. But this is, let's say, since we are following the requirement of the frame type, so this is already satisfied. So we can use this formulation and this formulation because we're already using this conditions. But anyway, the user has to take a look anyway after each layout. Well, so here you can see that the concrete strength is required, the yield strength is also required. For this reason, you have to use this number and you have to enter actually this one and this one. So for the moment, for this beam, let's use 3 bar 20, 4 bar 25, and the addition is 25, 25, extra is 12, and change please the diameter of the bar. So here we have number 12, you copy number 12 and you put it and click OK. Once you click on OK button, BMDealer actually gives you the option to change actually or to fix the framework dimensions. This is the span length, which is from here to here, from here to, and this actually equal to the bar length. But sometimes the model, it doesn't fit actually with the final situation, so you need to maybe increase, decrease, stretch up and maybe the each span. In this case, if you didn't like this, you can just say no, I didn't like, and you have to enter again. I'm gonna put like 580, 775, 580, and again. If you want to change as well the width of the support, you can also change, but I'm gonna keep it like this. This is actually very important because if you change this and you already know the final dimension or the framework of the beam, you can draw exactly the framework. See, okay. It's enough to put a 0 here and click on it. There you go. Something very important. Every time you launch the software, the beam detailer starts to draw the layout from the 0 point. So if you have anything in the 0 better you put it like up before the 0. Okay, here we have the beam number 12. As you can see here, this is the envelope. This is 12. This is the bar. This is the bar. This is file layer. You can turn off, turn on, and so on. Well, after you generate this drawing, beam detailing actually define some standards, dimension style, text style, layer, everything. Everything is on a different layer. Like for example, this dimension, this is the transverse reinforcement, and longitudinal reinforcement inside and outside the beam. Everything is on a different layer. Anyway. This is actually the algorithm of beam detailing. It follows to arrange the reinforcement. This is the basic reinforcement, this is the top, and this is the bottom, and this is the reinforcement, the skin reinforcement. Okay, let's take a look on this basic reinforcement. If we go again to user interface, we have here defined 320, but because of the 75%, the program automatically decreases the 320 and make it as a 314. 425 automatic change as 412, and the additional is used as a 25. You can see like here I have 125 plus 212 is the extra, because here it looks like I need one and here and like 2 point something 25. So instead of using 325, I use 2 plus 2 of bar 12. But for the top reinforcement, the additional top reinforcement is always based on this envelope. Let's take a close look to the envelope. The envelope is actually 5 diagrams. This one is the required top reinforcement, and this is equal exactly to the value in the text file. Like example, if you measure here, this is the white here is like it's called the 0 line. Distance from 0 to here, it's equal to 17.24. 17.24. Cool. Let's open this file and let's take a look. For this section, this is the location, you can check it in ETABS. The first value is 1724, but this is in square millimeter because you have always to export the result from ETABS in square millimeter and millimeter units. But here, if we go again to this, we'll see in the envelope it's saying like scale factor transfer bars and scale factor longitudinal. The scale factor for longitudinal bar to draw the envelope in square centimeter is 0.01. So this means that beam detailer automatically convert the reinforcement to square centimeter, and then you draw by scale factor equal to 0.01. So it means that this is in a square millimeter, but if you convert this to square centimeter, it will be 17.24. Or for the scale factor equal to 0.01, so it must be 0.1724, like here. So, and this is for this envelope, and let's see. Right, so this one is the required top reinforcement. If I turn on, if I turn off this one, I will have, and let's turn off this one. I have the red one. The red one is actually the additional top reinforcement. It means that this, according to this envelope, I should add some reinforcement. So at the end, the red reinforcement, this one, the red diagram, plus the basic reinforcement must be equal to the blue reinforcement, because this is the basic. This is the original. This is required. But I used basic reinforcement, so I kind of decreased this, or I pushed down this envelope. You can see here you have always a constant is equal to the basic reinforcement, and then you have to add some reinforcement, which is this top reinforcement. The additional top reinforcement is always arranged in this way. You have always a secondary top and a primary top reinforcement, and it's always to cover all the envelope diagram. The additional is, as I said, it's based on the envelope, and in the same time it's calculated and distributed and extended based on this. In the user manual, you have a good explanation about how BIM detailer extend the bar at each inflection point, and when even if you don't have any inflection point, the assumption to extend the bar. Here you have like the good expansion and the number, what each number means what, like example. Here you have two numbers, 229 to 11, which is equal actually the distance from the center of the subboard to the left edge is 229, and to the right is 211. BIM detailer draws the layout of the beam actually in a meter. So each value here is it's a meter, but with a scale factor equal to 100, so it's in centimeter. Well, so for the top reinforcement in the middle, we have this and this. This value is equal to the extension from the center, just to identify how much you should extend from each side. And well, the bottom reinforcement. Just turn on this. Sorry. Well, the bottom reinforcement, we have also two envelopes or two diagrams. We have this the required, and the other one is the additional bottom reinforcement. The required reinforcements, if you go back again, like AS inferior, it's equal. The bottom reinforcement. It's 747 square millimeter with a scale factor equal to 0.01, and to convert to square centimeter, so it must be 0.047. If we measure here at each point, at this point, so it's 0.074 centimeters. It's that square. If you turn off this and this, and this, you have the green envelope. The green envelope is, or the green diagram, is actually the additional bottom reinforcement, where you should add some reinforcement. So this reinforcement, not this is the basic. This reinforcement is based on this diagram. You can measure each value, like example here. Here it's 13 square centimeter. What do we have here? We have here 325 to cover this 13 square centimeter. It's very easy to work with BIM detailer because you have all the information available for you inside the AutoCAD. You just need to be a bit familiar with AutoCAD, and you have everything. You don't need to open either ETABS or anything. All the information you need are here. Since you have the envelope, so you can do the detailing. And this is what we have done actually. But if the user wants to, like example, to change or to modify anything, it's so easy because you have already the envelopes. So this is the top and the bottom. For the transverse reinforcement, we have here. Well, in this film example, we have 3 transfers for each span, because Here it was 700, so we don't have, no, the clear span, no. This is the maximum, the biggest one is 675, so it's less than 700. If this span is more than 700, we'll get here like 5 transverse reinforcement zone. And if any of the spans are less than 250, we'll have just one. You can try to change this, like for example make it 600 and make this like as 480, and in this case we'll have here 5, and here we will have just beam detail also draws a section. This section is for this beam. The section will be actually when you have a different section. For example, here we have 50-70 for all the spans, so we just have one section. If the user wants to have more sections, it will be done, I think, manually, but it's easy just to copy this and modify it and mention where is the section. If there is another like another span with different section, in this case the beam detailer will draw another section with a new dimension. Okay, for the transverse reinforcement, this transverse reinforcement actually is calculated according to the envelope. This is the envelope diagram. It's the orange one, and this one is also in a scale factor. Here we say the scale factor for transverse reinforcement for square centimeter over centimeter. It's 1. That means what? Like example, let's go to the same station location. This is the first one. This is station location. So, in this station location, this is the reinforced quarter. It's at the transverse reinforcement, but this is in square millimeter over millimeter because it's extracted from EDAPS. So to convert this to square centimeter over centimeter, you have to actually divide over 10 with a scale factor equal to 1. So the value here must be equal to this divided by 10. It must be 0.09 because convert this to centimeter, a scale factor, draw it by one scale factor, and that's it. So if we measure here now 0. Yes, so it must be like this. That's correct. This is square centimeter over centimeter. So you know this, you can have the transverse reinforcement, but the transverse reinforcement has to satisfy the condition of the ACI according to the frame type. So all these calculations done by beam detailer, the distribution according to the station location, to the required reinforcement, and everything is done here automatically. All the calculation and everything. Well, a short memory really useful to actually to evaluate the basic reinforcement and the let's say the design bars. Here you have this memory. You have this memory. Here you have the weight of the bars in each cube for each cube meter. The concrete, the total transverse reinforcement weight, the top, the bottom, all the longitudinal, and the concrete and the steel strength. You have 4 numbers here, are the LDT, LAT, and LDB. LT is actually the development length for the top. LAT is the bar supplies but each one is for the diameter, for this diameter and for this material. LDB is the development length for the bottom reinforcement. LAB is the bar supply length for the bottom reinforcement. Usually this is equal to 1.3, this one according to the ACI. What we can do now is to change the basic reinforcement and maybe change some stuff just to know if this is good, or we can like optimize the reinforcement. We have here we change to 4. Okay, let's again. I'm gonna remain on the basic reinforcement and let's see what will happen. I'm gonna remain, so I will say do not change, so nothing will happen, and I'm gonna change this and put it like 10 and 10. So I will remain on the basic reinforcement I decided to use, and I'm gonna remain. I'm gonna change this, make it less. Okay, you have to change again the span. We put it 580, 775, and 580, and the columns are the same, and click on it. Okay, great. Well, so let's check. Here we have 117, and here we have 120. So in theory, this reinforcement is better than this, but we can take a closer look. Let's put this here and let's try to understand what happened. Well, take it one by one. The transverse, this one is much better. It's like 161, so that's so good. Let's put this in the green. So this one is better than this one. Okay, top here is 271, here's 273, so more or less the same. The bottom is 330, here is 266. So this bottom is better than this bottom, but this is transfer reinforcement, so it's better than this one. So I can do one between this one and this one, or I can do like example another maybe solution. Let's try a third one. Let's put 420 like example, and this is, and do not change. No, I didn't like this. Change it please. 675, 580, yes, and cut. It's so flexible, so easy to optimize the reinforcement by beam detailers. Just seconds, and you can reach the more or less the best detail. Well, this is 104. It's better than this because I have here the same, but for the bottom reinforcement I have 237. It's less even than the old one. And this is actually because I use the 420. It's less than this one, and the same. If you didn't like, you can change, like example, the top reinforcement. Try to optimize the top reinforcement and maybe the bottom reinforcement. Another thing is if you use the plan beam detailing, you have to work actually with this file, plan beam detailing. It works only with this one. In this case, you will carry out the detailing for all the beams and all the detected beams. Again, we have 14 beams. But in this case, you will not have the option to adjust the framework of the beam. Usually, what we do is we start. The first shot will be with the plan beam detailing. You draw all the beams, and then you can pick one by one, try to optimize it. This could be the faster way to reach the best design or the best reinforcement. Anyway, I think this video will help you to start up with a beam detailer as a new application, as a new software for engineers and for architects. You can always send us an email to our company for additional support, additional help, or even for a special request. Thank you so much.